In this next video, I'm going to work questions number 7 and 8 together on one video because they pertain to each other. What you're asked to do in both problems is you're asked to deal with a problem that's given to you where you have to work with laws of exponents. Now, something I want to point out before you watch my video. There's not just one way to work these problems to get a correct answer. So your instructor may have taught you a different way, you may have seen a different way in the past. The bottom line is, as long as you're sticking to laws of algebra with exponents, you're going to be getting the correct answer. One other thing I want to point out to you, it's pretty much a general rule in algebra, is that your final answer to a problem normally should not contain negative exponents. So in these problems, we're going to adhere to that rule. Even though it may not say it specifically, it may say simplify or use laws of exponents to simplify. When you're done, just sort of a pretty standard agreement in math is that you don't leave negative exponents in your final answer. Alright, so with that said, let's go down to my paper and we'll look at these two problems. Okay, here we are. Let me get the cord out of the way. Question number 7 asks me, whoops, let's get the paper holding on, there we go. It asks me to take this quantity and raise it to the negative second power. Now, remember what this negative 2 goes with. It goes with both the numerator and the denominator, so I'm going to show that. I'm going to rewrite this by saying 2 on the top is actually being raised to the negative second power. 5 in the denominator is also being raised to the negative second power. So far what I've really done is I've showed some work. When a quantity, a fraction, is being raised to a power, that power affects the numerator and it also affects the denominator. Now, one other thing that I want to show you here is this. This is what I show students when I'm teaching this. It's one way of handling this, is basically a little rule that you may have heard in the past. Okay? When you see a negative exponent on the top, you're allowed to take this expression and move it down to the denominator and make the exponent positive and not change the base. Sort of like when you cross the line, you change the signs. Now, the 2 to the negative second on the top in the denominator is going to become 2 to the positive second power. The 5 to the negative second power in the denominator is going to move as 5 to the positive second power in the numerator. Again, when you cross the line, you change the signs. That's referring to a negative exponent becoming positive. Negative exponents take reciprocals is what's really happening. So that's why when you're moving from numerator to denominator, you're taking the reciprocal. The base does not change, it's just the exponent that does. To finish this problem, 5 squared in the numerator, of course, is 25. 2 squared in the denominator is 4. So my final answer to this problem is 25 over 4. Now, when I look at question number 8, x, y to the third on the top, x to the negative fifth, y to the eighth on the bottom, one way to approach this problem. I'm going to look at the x's as one problem. I'm going to look at the y's as another. Okay? So eventually we will get our final answer to this problem, but what I want to show you sort of as an intermittent step, I will eventually put the final answer here. But what I'd like to show you right now is this. In the numerator, I have x to the first. In the denominator, I have x to the negative fifth. When you're dividing, one law of exponents says you leave the base the same and the exponents get subtracted, starting with the top one. So we would have 1 minus a negative 5. Let's emulate that rule for the y's. When you're dividing, the base does not change. and you subtract the exponents starting with the top. 3 minus 8. When I do the arithmetic here, x remains the same, minus minus becomes a plus, 1 plus 5 is 6, y stays the same, 3 minus 8 is going to be a negative 5. Now even though x to the 6th, y to the negative 5th is an answer, again what I talked about earlier was you normally don't leave negative exponents in your final answer. So what I'd like to see in this problem as your final answer is you're going to create a fraction. X to the 6th would stay in the numerator, and y to the negative 5th would drop down to the denominator as y to the positive 5th. So our final answer, x to the 6th on the top, y to the 5th on the bottom. Thank you.